Today I'll be discussing about how to write the first C program, and we will also see the various steps of compilation of the C program. So before we start, we are going to get acquainted with a few commands, and these commands work for both Mac operating system as well as Linux operating system. So initially I would suggest that we create a directory of our own before starting, and each and every day's assignments that we will be working on, we will be storing them in that particular directory in an organized manner. So firstly, I'm going to create a directory of my own. So for that, I'll be using the command make directory or mkdir. Now mkdir, this particular command is responsible for creating a directory, and this works for both Linux as well as Mac. Let's consider that the name of the directory I am trying to create is AK_2024. Once I do this and I try listing the contents of the current working directory, I will see that AK_2024 has already been created. Now our objective will be to store all the assignments pertaining to the subject of structural and object-oriented programming into this particular folder. So in order to move into this folder, we will be using the second command, that is change directory or cd. cd AK_2024 is going to get us into the folder. How do we know that we are already inside the folder? For that, we have got the command pwd or the present working directory. Once we write the command pwd and execute it, it will show us our current location, where exactly we are located. Now inside this directory, we will create separate folders or separate directories for the assignments of each and every day that we will be working on. So for the first day, I'm going to create another directory here by the name lab1. So again, when I do the listing, I get to see that the folder lab1 has been created. Again, I change directory and I go into lab1, and the present working directory will be AK_2024/lab1. Now with this, we have already organized our directory structure, and now we will move on to writing our first C program. So we will be starting with the VI editor, which is the most primitive editor that the machines support nowadays. So VI hello.c, let this be the first C program that we intend to write. Hello.c is basically the C file, and since it is a C source code file, I have written it with the .c extension. All source code files of the C programming language have the .c extension. Now once I do this, this is the VI editor which has opened the new file hello.c. In order to enable typing into this particular file, we need to change our mode to insert mode, and we can go into the insert mode by pressing the key I from our keyboard. After we have entered the insert mode, let us now start typing something into the editor. Firstly, it's a good practice to start the program or start the source file by specifying the purpose of this particular file. So here I have given a multi-line comment, and inside this I'll be writing the purpose of the program. So this is our first program in C. We will learn the parts of the program and how we can execute it. So this is a multi-line comment that we have enabled. Also, we will write the name of the file in a single line comment. Let's call it hello.c. After this, we will be starting with the actual program. So in C, we start our program with the preprocessor directives. The most commonly used preprocessor directive in C programming language is the stdio.h header file, inclusion of the stdio.h header file. Now what does this mean? The stdio.h header file basically has the declaration of all the standard input-output functions. The purpose of this inclusion of this header file is to enable us to use the various standard input-output functions in the code. So once we have done this, we will also consider another preprocessor directive which is called hash define. This is mostly used to define macros, which we will again discuss in the subsequent classes. But for now, let's consider that we are defining a value n as 50, and then we will start with the main function. Now C follows a modularized approach. That means it is a procedural language. So it follows procedures. Everything is inside procedures in C. Here we have got the main function. Now this main function is the point from where the execution of the C program starts. We cannot change the case of this main function. It cannot start with a capital M, or it cannot be capital MAIN, because it's case sensitive, and this is the point from where the execution usually starts. How do I know that this main happens to be a function? Well, because of this first parenthesis open and close, this being placed right after the name of the function indicates that this is a function. Whenever we have got a function name followed by the first bracket open and close, we can say it is going to be a function. We can have values inside it, or we may not have values inside it, but the first bracket open and close always indicates that the word preceding it is going to be a function. Now inside this main function, we are going to give a function printf. The printf is the standard output function that is used, and it is declared in stdio.h. The printf function usually takes multiple parameters. It has got a variable length argument, so it can take any number of parameters. Usually the first parameter is the string that we want to display in the output screen. So let's say we want to display hello world. So I'm typing here hello world followed by \n, which is basically indicates a new line. So anything after this \n will come in the new line. So this is a class of %d students. Now %d is a placeholder, and the arguments placed after the first argument, that is the second argument onwards in the printf function, they will replace the placeholders based upon a first come first serve basis. So here we have got the first %d, and this is going to be replaced by this n over here, whose value has been defined to be 50 here. After this, we are going to just return 0. Now the purpose of this return 0, this keyword return here, is to return the value 0 to the calling function. Now in case of C programming language, when we try to compile a particular program, it is the operating system who calls the main function. So main function is always called by the operating system, and here we have considered the returned type to be an integer, and we are returning an integer value, that is 0 over here. Now why are we returning this 0 value? Returning 0 means that the execution of the program has been successful and there has been no abnormality. So that is why we are returning 0. In case of abnormal ending of the program, we give non-zero values. So since we are considering that the execution will go without any kind of error, so we are returning 0, and since 0 is an integer, we have set the data type of the return value from the main function to be integer as well. So with that, we have come to the end of our uh, program. Now what our objective will be to save this program. So in order to do that, we have to first press the escape key from our keyboard, and the moment we press the escape key, we come out of the insert mode. So in the bottom you see we are no longer in the insert mode. After this, we give the colon, which is basically shift then colon semicolon, that particular key we have to press, escape colon W. If we hit enter at this point of time, our program is going to get saved like this, but we will still be in the VI editor. The VI editor is still going to remain open. So in order to quit from this now, we have to give colon Q, or else together write and save can be done by giving WQ instead of just W or Q. So this is going to save the program, and at the same time we will be quitting the VI editor. So there we are. We have already come out of the VI editor. Now if I try to execute this program, or if I want to compile this program, for that I have to use the GCC compiler. GCC stands for GNUC compiler, and with that we write hello.c. So GCC filename.c. If we do that and we go for the listing, we find that an executable file a.out has been created in the directory. In order to execute this file, we have to write /a.out. This is going to execute the file. So once we do that, you can see in the output here we have hello world. This is a class of 50 students. So we have got our desired output. Now the question is, can there be multiple C files in a particular directory? Well, there can be. And what will be the executable file in case we have multiple .c files and we try to execute all of them, or in case we try to compile all of them? Well, let us first try to create a copy of the hello.c file. And in order to create a copy in Linux or in Mac, we use the command cp. Cp is responsible for copying. So let's say we have another file. We are copying the contents of hello.c into another file, goodmorning.c. If we try to list, we find that hello.c as well as goodmorning.c are there in the same directory. Now let us open this goodmorning.c and make some changes in it. So vi goodmorning.c. So this is again the same program as that of hello world, because we have just created a copy of it. So I'll just change the name of the program, and here instead of hello world we will simply just display good morning. Slight change. Now if we try to save it and get exit, so we will press escape colon WQ and we hit enter. So we come out of the VI editor. We have another command clear, just to clear the screen. So clear and enter will give us a clear screen. If I type the listing again, and I'll find that hello goodmorning.c is there, hello.c is there, and a.out is there. Remember, the last file that we had compiled is the hello.c file. So if we execute a.out, that means we are going to get hello world. This is a class of 50 students. Now if I try to compile the goodmorning.c and we try to list the contents of the directory, we again find that there is only one a.out file. If we try to execute that now, it will give us good morning. That means what? The new executable file that has been created has replaced the old executable file a.out. Hence what we need to do, we have to give separate names for separate executable files for each and every source code. That is going to keep copy of the executable files inside the directory. So what we will do now is we will simply just remove this a.out file. In order to remove or delete a file, we use the command rm. rm a.out is going to delete the a.out file from the directory. So you have got only goodmorning.c and hello.c. Now we will compile each of them separately and we will give a separate executable file name to both of them. So in order to do that, we will just write gcc filename.c -o and then the name of the executable file. So for this case, when I'm using that for hello.c, see, I have got the executable file hello. In order to execute it, if I just write /hello, I'll get hello world. Okay. Similarly, if I write gcc good morning.c minus o gm, I'm going to get another executable file here, that is gm, which is the executable file of the good morning.c, and hello, which is the executable file of hello.c. So if I execute gm now, I'll get good morning. This is a class of 50 students. So this is how we can create multiple executable files corresponding to each and every source files. Okay, now the next thing that I'll show you, that when we are saying that we are compiling a C file, we are actually going through 4 phases of compilation. The first phase is called the pre-processing phase, second one is called the compilation phase, third one is the assembling, and the fourth one is the linking phase. Each and every temporary file that is generated after each and every phase gets removed after the entire execution process, and it's only the executable files that remain when we use the command gcc filename.c minus o executable file name. So now what we will do is we will look into each and every intermediate files that are generated during the each and every steps of the compilation process. So the first compilation process is the pre-processing phase. So let us see what happens right after the pre-processing phase. Now in order to stop the compilation process right after the pre-processing phase, we have to use the command gcc -e filename.c. But before we go into that, I'm going to remove the executable files. So rm hello space gm, so that we are left out only with the source code files, that is the .c files. Now let's work with the hello.c. So our objective will be to stop the compilation process right after the creation of the right after the pre-processing phase. So for that, I'll write gcc -E hello.c, and this is what it looks like. Let's start from the bottom. See, this is the part where we have got the actual code, and here after the comma in this part we had the macro n written over here. So one of the jobs done by the pre-processing phase of the compilation procedure is to replace the macros throughout the program using the values that are provided. Second thing you can notice here is that before the main function, before this int main, the header file is no longer there, the comments are no longer there. So job number 2 that is being done by this pre-processing phase is stripping off the comments. So there is no comments that is available anymore. And number 3 is it replaces the statement #include stdio.h with the actual contents of the stdio.h. So this is the content of the file stdio.h. As you can see, it has replaced the statement #include stdio.h. So this is what looks like right after the pre-processing phase is over. Now after the pre-processing phase, next comes the compilation phase. So the outcome of the compilation phase is the assembly language code. So in order to get that assembly language code, our next step will be gcc -S then filename.c. So this particular command is going to stop the execution or stop the compilation process right after the step 2 or the second phase of the compilation process. So let's do that, and when we hit ls, now you can see that there is a new file in the directory hello.s. So what is this hello.s? This hello.s is basically the assembly language code corresponding to the C file hello.c. So let us now open this hello.s and look into it, what exactly it has. So vi hello.s. Once we hit enter, this is what we can get to see. So this is the content of the This is the assembly language code corresponding to the C file that we had written. Here, assembly language code usually has a set of instructions which are given over here: move, str, stur, adrp, add, move, str, ldr, ldp, add, ret. Ret is corresponding to return. And along with this, we can see the various registers: x0, x0, x9, x8, x8. These are all the register memory that is being used, or being used by the CPU to perform the jobs that are given by the high level language in C. These are the CPU registers that are used during the compilation process by the CPU. Now we know that the register memory is the nearest to the CPU because they are located in the CPU itself. So they are the costliest form of memory, and the access time to these registers are minimal. So what the CPU does is, whenever it performs any kind of execution, it simply just brings contents from the main memory to the registers, processes them, and then sends them back to the main memory. So here we have got the set of instructions, and on the right hand side here we have got the registers and the various kinds of operations that is being done. So this is what the assembly language code looks like. Now after the assembly language code is obtained, this assembly language codes file, that is hello.s, this is fed as an input to the assembler. And after the assembling is done, the outcome is going to be the object file, that is hello.o. Now in order to perform the job of the assembler, or in order to stop the compilation process right after the assembling of the code, we have to compile it with the -c flag. So gcc -c hello.c, this is going to simply start the compilation procedure, and it is going to end after the stage 3 of the compilation process, that is after the assembling process. So once I do this, am going to get a file hello.o. So this hello.o is written in machine language. So if we just open it up, we will be able to see how it looks like, but obviously it's going to be in a non-human readable format, which is something like this. So this is what it is. Here you can see the string hello world which we intend to display, but the rest of the contents are all in a non-human readable format. I'll again come out of here, and finally is the last step, is the linking phase. After the linking phase, we get to see the executable file. So we can directly go to that phase by simply just writing gcc hello.c -o hello. This is going to give us the executable file hello. So /hello, we are going to get the outcome, which is hello world. This is a class of 50 students. So that's all. That's the discussion for today. Thank you everyone.